So our last video for this chapter is determining which measure of central tendency we should be using when we're looking at a data set. So I'm just going to give you some examples of when to use the mean, when to use the median, and when to use the mode. So let's start off when to use the mean. So when you have a symmetric distribution, remember a symmetric distribution means that your mean, median, and mode are all the same value or close to the same value. They don't have to be exact, but around and about the same value. That means that any one of those three really can be a good descriptor of your data set. We tend to go with mean in that particular instance. We tend to use mean because it uses all of the data collected to calculate it, and additionally it is closely related to variance and standard deviation, which we will be learning about in the next chapter. So it comes in valuable when we want to talk about inferential statistics. So remember, descriptive statistics, which is what we're doing right now, just tells us about the data that we're looking at. Inferential statistics is what we do to predict back into our population. Okay, now when not to use the mean. So when there are outliers present, the mean is usually not a very good representation of what the data shows. So for example, I have the salaries for 10 staff members, and if you want to pause the video really quick and figure out the mean on your own, you can do that. If not, the mean for this data is going to be 30.7K or 30,700. But hopefully if you looked at this data, you can see that these last two people, staff number 9 and 10, make up a substantially large amount of money compared to the rest of the staff members. So look what happens if we remove staff members 9 and 10 and just calculate the mean with 1 through 8. So if we do that and we calculate the mean of staff members 1 through 8, we're going to get that the mean is 15.25K. So 15,250. And that really honestly seems a little bit more accurate to the majority of the staff members that we have salaries on here. So it just kind of as a side note, whenever our data is skewed, whether it's skewed positive or negative, it really doesn't matter which direction. Our mean really does lose the ability to provide a best central location because the data drags it one way or another, because you are using all of the data. So when you have these large numbers, or small numbers for that matter, they tend to really affect the mean, whereas they don't affect the median and the mode as much. So sometimes when we notice outliers, we'll either remove them, like we did here with the 90,000 and the 95,000, or we'll use one of our other measures of central tendency to tell us more about or describe the data a little better. So then let's talk about when we're going to use mean. So one of the reasons median. One of the reasons would be for extreme values, like we saw in the previous example, where those two employees really skewed our mean. So median does not get skewed by extreme values. When there are some missing or undetermined values, so if we have something missing, then we like to go for the median. Open-ended distribution, so things that don't ever stop or end, we like to use the median. It's a little bit cumbersome to figure out what the median is, but we do like to use it in that instance. And when our data is measured on an ordinal scale. So remember, ordinal scales are categories that you can rank. So we like to do our median on ordinal scales. So an example, again, I'm going to go back to the same things we were just talking about, our staff salary. And if you'd like to pause the video and figure out the median on your own, remember you got to put the numbers in order, and you're going to do that middle number. Since we have 10 data points, you would need to find the average of the center 2 data points. But again, remember, after you put them in numerical order. So if you figured out the mean, hopefully you found out that it was 15.5K or 15,500. if you think about that, notice that that is much closer to our mean when we took out our outliers. So you can see that the median just is not affected by those outliers like the mean is. So that's one of the reasons we tend to gravitate towards the median when we have numbers that are vastly different from the average or the most of our numbers there. So when to use modes. Remember, mode is the number that occurs the most often. Typically, we use those on nominal and ordinal scales. Remember, nominal and ordinal scales are those categorical scales. Nominal we cannot rank. Ordinal we can. So remember, nominal is things like your eye color, your race or gender, your hair color, things like that. Ordinal scales are things we can rank in order. The reason we go with mode for this is because you can't find the mean and the median for nominal and ordinal data. Those don't exist because we're talking about categories. On discrete variables are often whole numbers, and that can be calculated easily. For example, the number of dogs per household in 2008 was 1.6. That's not really a reasonable answer because you can't have 1.6 dogs. So the mode would be a much more accurate representation of the number of dogs most people have in their household. Instead of that, it's kind of like the age-old thing about the average couple in America having 2.5 children. You can't really have half a child, so that's kind of where you get that, where we want to talk about the mode versus talking about the mean. And then when we're describing the shape of a data, we tend to go for mode. So you can say something is unimodal, which means it has one mode, or bimodal, which would mean it has two modes, or even multimodal, which means it would have more than 3 or more modes. So you can kind of sometimes use the mode as a helping to describe the shape of your graph itself. If you have any questions about when you want to use the mean, median, and mode, please make sure to let me know. Have a great day.